Okay, so now let's consider another problem. Writing a Turing machine that only accepts any palindrome of even length. Okay, so palindrome of even length, what's an example? 101101. So how can we write such a machine to recognize these strings? We want to write a machine that, like, if the string's blank, then it immediately accepts. Otherwise, it deletes the first character, checks if the last character is the same and deletes that too, and then rinse repeat. So that's the rough sketch of the algorithm we're going to use. Have a go at implementing it, and then, pause the video for a moment, have a go yourself, and then we'll go through it together. Okay, so let's have a go at building such a machine. So, got my start state here. If the string's blank, that's certainly an even length palindrome, so we finish and we say yes immediately. Okay, otherwise I'm going to do one of two things. I'm either going to delete a 1 and then have some section of the Turing machine for remembering that a 1 was deleted, or delete a 0 and then have a section of the Turing machine for remembering a 0 was deleted. So we'll consider the case for 1, and the other case will be analogous. So I'll call this R1 for remember 1, CA1, write a blank, and step left. Okay, so I've got my tape here, 1, 1, 0, 1. 1, 0, I'll put it up here out of the way. 1, 0, 1, 1, 0, 1. So if I delete the first character, then I should whiz all the way down the string to the right hand side and check if it's the same thing. So C1, write a blank, move left, so I'm pointing here. Fly all the way down to the end of the string. So C0s, write zeros, move right. This should also be a right. Whoops. Because C1, write a blank, move right. C0s, put them back, move right. C1s, put them back, move right. C a blank, write a blank, move left. So that means they go down the string and then back up 1. If I see a 1, delete it. And if I see a 0, then get stuck and reject. So that means I only put in the transition for the 1. So remember 1, 2, I guess. If I see a 1, delete the 1, step left. See a 1, write a blank, move left, and then we have some state to go all the way back to the beginning and start all over again. So we'll call it rewind. C0, write 0, move left. See a 1, write a 1, move left. See a blank, write a blank, move right, and then go back to the start. See a blank, write a blank, move right, start all over again. And then we can have an analogous case for the 0, just as before. So remember 0. See a 0, write a blank, move right. Move all the way along to the end. See a blank, write a blank, move left. And this time, if I see a 0, write a blank, move left. If I see something else, then I get stuck. Okay? That looks like a reasonable guess for the machine. Let's give it a test. So 1, 0, 1, 1. Oh, let me get my little tape so we can line everything up nice and neat. Here it is. 1, 0, 1, 1, 0, 1. Now we'll shift it all over. Okay, so we start on the left-hand side like we usually do. So CA1, write a blank, move right. Now transition to R1, fly all the way down to the end of the string, see a blank, write a blank, move left, see a 1, write a blank, move left, rewind all the way back to the start of the string, see a blank, write a blank, move right, so we follow this transition back to S0, start all over again, delete a 0, is this a 0? Yes, delete it, see a 1, delete it, see a 1, delete it, so then see a blank, write a blank, move right. So we'll be here actually. See a blank, write a blank, stay, hold. Okay, that seems to work. So let's try it for something that isn't an even length palindrome. I guess we'll try an odd length palindrome. Or something that isn't a palindrome. 1, 0, 1, 0, 1. So what happens here? Delete the 1, delete the 1, delete the 0, delete the 0, delete the 1. And then what it will do, so 1, write a blank, move right, blank, write a blank, move left, and then it gets stuck because there's no 1 to delete. So then it gets stuck in a rejecting state and it rejects. And if we have something that isn't a palindrome, then it's immediately going to get stuck. So we're in state S0, see a 1, write a blank, move right. Go all the way to the far side. See a blank, write a blank, take a step back left. See a 1, write a blank, move left. But I see a 0. Oops, looks like I'm stuck. So again, I reject. Cool. So this looks like it's a Turing machine that does indeed accept the language of all even-length palindromes. In the next video, we're going to go through an example for odd-length palindromes. So have a go right now of writing a similar machine that only accepts odd-length palindromes, then we'll go through the solution in the next video.